Why do we carry out meshing in finite element analysis? Divide and rule. Yeah, that's why. We divide the complex problem into small parts, and that's where the term meshing comes from. If you have a part or geometry, it has infinite number of molecules because it's continuous. If you want solution to this problem, then you need to solve infinite simultaneous equations, which is impossible even if you have supercomputer. So we divide the part or geometry to get finite number of equations. So now you can solve the problem with same geometric representation and without compromising the accuracy. So that's why we do meshing. You can read about the mesh convergence further to know the size of element vs accuracy of results. One of the purposes of meshing is to actually make the problem solvable using finite element. By meshing, you break up the domain into pieces, each piece representing an element. You need these elements to be able to apply finite element, since finite element is all about having a basis local to an element and stitching a bunch of local solutions together to build the global one. If you did not mesh and just assumed some basis that covered the whole domain, that would be a spectral method. One other aspect of meshing is accuracy of your solution. It can be shown that your global solution accuracy is a function of element width and the smallest angle at some element's vertices. Due to these contributors to accuracy, it's important to be careful about how you implement your mesh to ensure angles within elements are larger. Smaller angles hurts accuracy, and that you get it sufficiently refined to get the accuracy you wish. If you want to try and avoid all of this, there are approaches out there called meshless methods, which basically solve problems based on particle clouds and typically using some nearest neighbor algorithms, radial basis functions, and potentially collocation approaches. Something that might be interesting to look into.